This is your exponential growth and decay review. Circle the appropriate description of each graph and equation below. This one from the left is going to go up, so this one's going to be growth. From the left, this one goes down. This one's going to be decay. Looking at your multiplier right here, 5 over 2. If you're not sure what that actually looks like, even though it's a fraction, it is an improper fraction, which means it's going to be greater than 1. So it's going to be growth. If you're not sure if it's greater than 1, you can actually type it in. 5 divided by 2. And you can see over here that it is 2.5. So that you can see that is greater than 1. Over here, 2/7. This is your multiplier. This is your B value. This is a fraction, and it is less than 1, so it's going to be decay. You can also type these in to see that it's going to go growth, and then to see that it's going to go decay. Circle the appropriate ending to the sentence. All exponential growth functions have a B value that is greater than 1. So we want growth, so that's going to be greater than 1. The next section, identify the growth decay given the growth decay factor, the initial value, the horizontal asymptote, fill in the table value, state the domain and range. So for this one, we're going to go type in, given y equals 2 times 3 to the x, and then we're going to answer all of our questions based on that. You can see that the graph is going to be growth. I can also see from this B value, when I'm multiplying by 3 every time, that is going to get bigger. My values are going to get bigger in my table. So this is going to be growth. The factor, the growth factor, is this B value. I'm going to write B above here, and that's 3. My initial value, that's my A value. That's the one in front. That's your y-intercept. And that is 2. Your asymptote, this is approaching but will not cross. And if we zoom in, we can see that it's not going to actually cross or touch that x-axis, but it's going to try to get really close. Y equals 0. And you can type that in, y equals 0, so that you can see that is your x-axis. Your domain, since we are dealing with just a function, and we do have arrows that it continues forever to the left, and it's going to keep going up and to the right, that's going to be all real numbers. Your range, how low is your graph going to go? Well, it's going to get really close to that 0, but it's not going to cross or touch. And it's going to go up, 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 and it's going to keep going infinite forever. So we have y, and we have our boundary at 0, and it's everything that is bigger than 0. Not equal to, because there's that asymptote. And then we're going to fill in our table. So we can change it to a table. And we have our x and our y values. And we can start writing some of these in. This value right here, -1, is going to be 2/3. And that's what 0.6 repeating is as a fraction, or you could just write that one down. 0, 2, 1, 6, 2, 18. And we can see here that we are multiplying by 3 every time. Times 3, times 3, and so on. And that would also be here, times 3. You're going to do the same thing for the one right next to it. We have a new function that we're going to type. We're going to type y equals 1.9 times 0.2. Or if you're typing in the 0, be careful, it's 0.2. 2/10 to the x power. I think I forgot my y in the front. There we go. I was getting an error message. Now we have our graph. Is this growth or decay? So from the left, it's going to go down, so it's going to be decay. I can also tell because my B value is less than 1. This is a number smaller than 1, so that means that our values in our table are going to go down. They're going to become less. What is the factor? Our factor, our multiplier, is that B value, and that's 0.2. Our initial value is that A value. That's your y-intercept when you're graphing. And so you can see it here also, the 1.9 and then the 1.9. And the asymptote again, your line is approaching, but it is not touching. Y equals 0, which is your x-axis. Since it is a function with no real-world situation, we use all of our numbers. Our graph is going forever and ever to the left, forever and ever to the right. So infinity and infinity, so that's going to be all real numbers. That's a little bit different when we have a word problem. And our range, how low is it going to go? It's going to get really close to this x-axis, but it's not going to touch. And again, you can see that when you start to zoom in. You can see that it's getting really close, but it's not actually touching. So we're going to get really close to that 0. How high does it go? It's going to keep going. So our boundary is at 0. And it's just greater than. It's all those numbers that are bigger than 0. For a real world situation, again, these will be a little bit different. Now we're going to fill in our table. So we change it to a table. And we want some negative values and some positive values. So I'm going to go -2 is 47.5, -1 is 9.5, 0 is 1.9, and 1 is decimal 38 hundredths. So you guys are welcome to pick any values you want. If you want to add different values and move your table, you are welcome to do so. You can add whatever values you want in the table. These just happen to be the easiest for what I was doing in this question.